Hi students, today we are going to discuss a very important topic, that is sequence and series, which is useful for class 10th as well as intermediate. Okay, sequence and series. What is sequence? Sequence is an arrangement of numbers in a definite order according to some rule. A sequence is an arrangement of numbers in a definite order according to some rule. That means a set of numbers are arranged in a definite order. A set of numbers arranged in a definite order. Order is nothing but either ascending order or descending order according to some definite rule, means it follows some logical rule, then it is called sequence. Observe here example 10, 7, 4 and so on. It is arranged in a definite order, that is descending order. It follows some logical rule, that means every term except first term, if we subtract from preceding term we get next term. 3 subtract from preceding term we get next term. That is some logical rule. It follows some logical rule, then this is called what? Sequence. For example, second one 0, 1, 1, 2, 3, 5, 8 and so on. Observe here, it follows some order, that is ascending order, and it follows some logical rule, that is every term except first 2 terms we add preceding 2 terms, we get next term. Observe here, 0 plus 1, 1, 1 plus 1, 2, 1 plus 2, 3, 2 plus 3, 5, 3 plus 5, 8, next 5 plus 8, 13 and so on. It is a sequence. Sequence means sequence is nothing but arrangement of numbers in a definite order according to some definite rule, then it is called sequence. Or a sequence is a function whose domain is set of natural numbers. A sequence is a function whose domain is set of natural number. For example, f of x is equals to 2x plus 1 for all x belongs to n. A sequence is a function whose domain is a set of natural number. If you substitute x value 1, 2 1s are 2 plus 1, we get 3. If you substitute x value 2, 2 2s are 4, 4 plus 1, we get 5. If you substitute x value 3, 2 3s are 6, 6 plus 1, 7 and so on. This is a sequence. That means a sequence is a function whose domain is the set of natural number. A sequence is a function whose domain is the set of natural numbers and the range is the subset of real numbers, then it is called real sequence. A sequence is a function whose domain is the set of natural number and whose range is the subset of complex numbers, then it is called complex sequence. Then it is called what? Complex sequence. Observe here, a sequence is nothing but arrangement of numbers. The various numbers occurring in a sequence, is called its terms. Generally, terms are denoted by A1, A2, A3 and so on, or T1, T2, T3 and so on. Generally terms are denoted by A1, A2, A3, A4 and so on, or T1, T2, term 1, term 2, term 3, that means T1, T2, T3, T4 and so on. The various numbers occurring in a sequence is called its terms. Okay, next, series. Series means the sum of terms of the sequence is called series. The sum of the terms. The sum of the terms of a sequence is called series. Or in a sequence, each term connected by plus or minus sign, then we get series. Each term connected by plus or minus sign, then series is obtained. For example, if A1, A2, A3 and so on is a sequence, then the expression A1 plus A2 plus A3 plus and so on is a series. For example 1, 5, 9, 13 and so on is a sequence. Then 1 plus 5 plus 9 plus 13 plus and so on is a series. That means the sum of the terms of a sequence, is called series. Okay, series is two types, that is finite series or infinite series. Finite series means a series has finite number of terms, then it is called finite series. Infinite series means a series has infinite number of terms, then it is called infinite series. For example, observe here 1 plus 3 plus 5 plus and so on plus 21. Observe here, this series has finite number of terms, so this is called finite series. Example here, infinite series means 2 plus 4 plus 6 plus 8 plus and so on. Observe here, this series has infinite number of terms, infinite number of terms, so this is called infinite series. Now we are going to progression. What is a progression? Progression means in a sequence each term follow a certain pattern, then it is called progression. In a sequence each term follow a certain pattern, then it is called progression. Or sequences following specific pattern, then it is called progression. Sequences following a specific pattern, then it is called progression. Sequences following a specific pattern according to some rule, then it is called a progression. For example, 1, 6, 11, 16, 21 and so on is a progression. It follows some specific pattern, and 2, 4, 8, 16, 32 and so on. This is a progression. Or 1 by 3, 1 by 6, 1 by 9 and so on. This is also a progression. What is the main difference between a progression and a sequence means? A progression has a specific formula to calculate their nth term, whereas sequence based on some logical conditions which does not have any formula to find their nth term. That is the main difference between the progression and a sequence. Okay. Progressions are mainly 5 types. First one is arithmetic progression. Arithmetic progression. AP. Second one is geometric progression. That is GP. Next, third one is arithmetico geometric progression. That is AGB. Next, fourth one is harmonic progression. HB. Next, fifth one is miscellaneous progression. Miscellaneous progression is nothing but some progressions 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on. This type of progressions are called miscellaneous progressions. Now we are going to discuss one by one. First one is arithmetic progression. First one is arithmetic progression. That means AP. Arithmetic progression. A progression is said to be arithmetic progression. A progression is said to be a arithmetic progression if the difference of a particular term and just previous term. The difference of a particular term and just previous term is always same or constant. A progression is said to be arithmetic progression if the difference of a particular term and just previous term is always constant. Or a sequence is said to be arithmetic progression. A sequence is said to be arithmetic progression if the difference between any two consecutive terms, the difference between any two consecutive terms is always same or constant. A sequence is said to be arithmetic progression if the difference between any two consecutive terms, is same or constant, then it is called arithmetic progression. For example, 1, 3, 5, 7, 9 and so on. Observe here this sequence the difference between any two consecutive terms, 3 minus 1, 2, 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. The difference between any two consecutive terms is always same or constant, then it is called what? Arithmetic progression. So this sequence is in arithmetic progression. If A1, A2, A3, A4 and so on, AN are in arithmetic progression, then the difference between any two consecutive terms is a constant, that means are same. That means A2 minus A1 as same as A3 minus A2 same as A4 minus A3 and so on. AN before term is AN minus 1. So AN minus 1 is same and constant. That constant quantity is denoted by D. That means common difference. That means what? D means common difference. Okay. Next, A is the first term. A is the first term and D be the common difference. Then arithmetic progression can be written as A plus D, A plus 2D, A plus 3D and so on. A is the first term, D is the common difference, then the general form or arithmetic progression can be written as A plus D, A plus 2D, A plus 3D and so on. We know that progression has a specific formula to calculate their nth term. Here we derive a formula, nth term of arithmetic progression or general term of arithmetic progression. Nth term or general term of an arithmetic progression. Nth term or general term of an arithmetic progression. We know that A is the first term, D is the common difference. A is the first term and D is the common difference. The general form of arithmetic progression is A plus D, A plus 2D, A plus 3D and so on. That means this is the first term, second term, third term, fourth term and so on. First term is nothing but A1 or T1 is equals to what? Here A. Okay. Second term is nothing but A2 or T2 is equals to A plus D. Third term A3 or T3 is equals to A plus 2D. Fourth term A4 or T4 is equals to A plus 3D. Observe here, first term A1 is how much? A. We know that 0 is an additive identity. So A can be written as A plus 0. 0 into anything is a 0. So A plus 0 into D. That is A only. That is equals to 0 can be written as our convenience. This is first term. So 0 can be written as A plus 1 minus 1 into D. 1 minus 1 how much? 0. Can't be change anything. Next, second term A2. That means A plus D. A plus D is nothing but A plus 1 into D. 1 can be written as our convenience A plus 2 minus 1 into D. Second term, so A plus 2 minus 1 into D, that is equals to third term A3 is equals to A plus 2D. 2 can be written as our convenience here third term, so A plus 3 minus 1 into D, the position of the term. we use the position of term here. Next, A4, 3 can be written as A plus 4 minus 1 into D and so on. Observe here, we want A nth term. A1 means A plus 1 minus 1 into D. A2 means A plus 2 minus 1 into D. 2 means 2 minus 1 into D. A3 means A plus 3 minus 1 into D. A4 means A plus 4 minus 1 into D. Observe this pattern. We generalize AN is equals to A4 means 4 minus 1. AN means A plus N minus 1 into D. This is called the nth term or general term of an arithmetic progression. This is called the nth term or general term of arithmetic progression or last term of the arithmetic progression. Sometimes they are asking, what is the nth term? What is the nth term from the end of an AB? L is the last term. L be the last term. L be the last term. Very, very important. L be the last term. We want mth term. Mth term from the end. Mth term, D be the common difference. We want mth term from the end is nothing but dash, Tm dash from the end. Tm dash is equals to formula L minus M minus 1 into D. L minus M minus 1 into D. If L is given and a common difference is given, we want T mth term from the end. T mth term from the end is Tm dash is equals to L minus M minus 1 into D. Next, second point. Observe this progression. 2, 4, 6, 8, 10, 12, 14, 16, 18. Observe this progression. Mth term from the end. Mth term from the end of an AP is equals to N minus M plus 1th term from the beginning. That means third term from the end of third term from the end of an AP. That means third term is 14. Third term here number of terms 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 minus 3 plus 1. 9 minus 3 plus 1. 9 minus 3, 6 plus 1. That equals 7. Observe here. 1, 2, 3, 4, 5, 6, 7. Both are same. So mth term from an end of an AP. Mth term from an end of an AP is equals to N minus M plus 1. M minus mth term from an end of AB is equals to N minus M plus 1th term from beginning. Mth term from the end of an AP is equals to N minus M plus 1th term from the beginning. How to ask the questions about a nth term means, for example, For example, 10, 7, 4 and so on. What is the 30th term? What is the 30th term? We find a 30th term. Here observe that a 30th term. Here observe that first term is nothing but a is equals to 10. Common difference. This sequence clearly it is in AP. 7 minus 10 minus 3. 4 minus 7 is also minus 3. So it is clearly it is in AP. So common difference D is equals to A2 minus A1. Nothing but 7 minus 10, that is equals to minus 3. We want a 30th term, that is equals to a plus 2090. An means a plus n minus 1 into d. A 30th term means a plus 30 minus 1 into d. Nothing but a plus 2090. That is equals here a value 10 plus 29 into minus 3. That is equals 10 minus 23 is 60, 3 9 is 27. That is 29 3 is 87. That is equals 10 minus 87 is nothing but minus 77. Next, sometimes they are asking like that. Second example, what is the first negative terms? What is the first negative terms of the sequence 20, 19 and 1 by 4, 18 and 1 by 2, 17 and 3 by 4, and so on? What is the first negative term? Which is the first negative terms of the sequence? Means clearly it is in AB. Observe here, A2 minus A1 is equals to 19 and 1 by 4 minus 20. 19 4 76, 76 plus 1 77 by 4 minus 20. That is equals, if you do LCM, 77 minus 80 by 4, that is equals to minus 3 by 4. Next, A3 minus A2, A3 minus A2, here 18 and 1 by 2 minus 19 and 1 by 4, 18 2s are 36, this is mixed fraction converted into improper fraction, 18 2s are 36, 36 from 37, 37 by 2 minus 19 4, 76 plus 1, 77 by 4, LCM 4, 2 2s are 4, 2 37s are 70. 4 minus 77, that is equals to minus 3 by 4. A4 minus A3, that is 17 and 3 by 4 minus 18 and 1 by 2, that is equals to 17 4 68, 68 plus 3 71, 71 by 4 minus 18 2s of 36, 36 plus 1 37 by 2, that is equals 71 minus, if you do LCM, 71 minus, LCM is 4, 2 2s are 4, 2 37s are 74, that is equals to minus 3 by 4. Here, the difference between any two consecutive terms is always same, so it is in AP. It is in AP. So, first term is A, and common difference D is equals to minus 3 by 4. We want which is the first negative term. Which is the first negative term. Let us assume that the first negative term may be AN. Let the first negative term may be AN. We want first negative term means AN is less than 0. We know that AN means A plus N minus 1 into D is less than 0. Here A means 20 plus N minus 1 into minus 3 by 4 is less than 0, D value minus 3 by 4. 20 minus 3 by 4 into N minus 3N by 4 minus into minus plus 3 by 4 is less than 0. 20 plus 3 by 4, 420 is 80, 80 plus 3, 80, 3 by 4 minus 3N by 4 is less than 0. If you do LCM, 83 minus 3N is less than 0 into 4 is nothing but 0. 3N is greater than 83 is less than 3N, that is 3N is greater than 83. N is greater than 83 by 3. 27 3s are 81, that is equals to 27. N is greater than 27. 27 3s are 81, 27 and 2 by 3. N means number of terms. Number of terms is always a positive integer. So N 27th term, 27 greater than N. So N is greater than 27 and 2 by 3. So N is equals to, so 28th term is the first negative. 28th term is the first negative term. That is A28. A28 is equals to A plus 27. A value here 20 plus 27 into minus 3 by 4, that is equals to 20 minus 81 by 4, that is equal to 420s are 80 minus 81 by 4, that is equals to minus 1 by 4. That is the first negative terms. That is the second example. Next, third example. Third example, example 3. 100 times, 100 times of the 100 times of 100th term, 100 times of 100th term with non-zero common difference, is equals to 50 times of 50th term, then find 150th term. Then find the 150th term. That means given that 100 times of 100th term, 100 times of 100th term is equals to 50 times of 50th term, then find A150 or T150. 100 times of 100th term with non-zero common difference is equals to 50 times of 50th term, then find the A150th term. We know that Tn is equals to A plus n minus 1 into D. That is equals to 100 into A plus 100 minus 1 into D. That is nothing but 99D is equals to 50 into T50 means A plus 50 minus 1 49D. 50 ones are 50 twos are 2 into A 2A plus 2 into 99 198D is equals to A plus 49D. If you transpose like terms, 2A minus A is equals to 49D minus 198D. 2A minus A is nothing but A. 49 minus 198. 18 minus 9, 9 only. Next, 8 minus 4, 4, 1, 149D. If you transpose plus 149D to RHS to LHS, plus quantity becomes minus quantity. So, A minus 149D is equals to how much? 0. This is minus 149D. So, this is minus quantity becomes plus quantity. So, A plus 149D is equals to 0. Why? Because 49D minus 198D is nothing but minus 149D. Minus quantity, transpose minus quantity to RHS to LHS, we get plus quantity. So, A plus 149D is equals to 0. That is A 150th term is equals to 0. Okay. Next, derive a formula for sum of first n terms in arithmetic progression. Sum of first n terms in an arithmetic progression. We know that A is the first term and D is the common difference. The general form of arithmetic progression can be written as that is A plus D, A plus 2D, A plus 3D and so on, A plus n minus 1 into D. Okay, we want their sum. Sum of first n terms is denoted by Sn. Sn is equals to A plus D plus A plus 2D plus A plus 3D plus and so on, A plus n minus 1 into D. This is equation number 1. We use here the method, the Carl Friedrich Gauss method we use, that is Sn is equals to, write reverse order, that is A plus n minus 1 into D. N minus 1 before term is A plus n minus 2 into D plus and so on, that is A. This is equation number 2. Add equation number 1 and 2, that is 1 plus 2. We get Sn plus Sn 2 times of Sn is equals to A plus n minus 1 into D. How much? 2A plus n minus 1 into D plus A plus D plus A plus n minus 2 into D. A plus A 2A plus n minus 2D plus D, that is minus D, that is 2A plus n minus 1 into D plus and so on. This is also 2A plus n minus 1 into D. 2A plus n minus 1 into 2A plus n minus 1 into 2A plus 1 into n minus 1 into d. How many times? N times. N times. That is n times. Okay, a 2Sn can be written as 2Sn is equals to 2 times of Sn is equals to n into 2a plus n minus 1 into d. Why? Because 2a plus n minus 1 into d are in n times. So n into 2a plus n minus 1 into d. 2 can be transposed from LHS to RHS. Multiplication quantity becomes division quantity. So Sn is equals to n by 2 into 2a plus n minus 1 into d. This is the formula for sum of first n terms in arithmetic progression. Okay, or Sn is equals to n by 2 into 2a can be written as a plus n minus 1 into d. A plus n minus 1 into d is nothing but an. So Sn is equals to n by 2 into a plus an, or a plus L also, last term, a plus L. Here we discuss one or two examples. Sum of first n terms. Okay, example 1. How many terms are added to be make their sum is 52 in the sequence minus 8 plus minus 6 plus minus 4 plus and so on? How many terms are added to make their sum is 52? That means Sn is equals to 52. How many terms are to be added? To make their sum is 52. That means Sn is equals to 52. Here a is equals to, clearly it is in AB. A is equals to minus 8. Common difference d is equals to minus 6 plus 8, that is equals to 2. That is 8 to minus 7, that is equals to how much? 2. We know that Sn is equals to n by 2 into 2a plus n minus 1 into d. That is n by 2 into 2a plus n minus 1 into d is equals to how much? 52. Why? Because Sn is equals to 52. So n by 2 into 2a, a value here minus 8 plus n minus 1 into 2 is equals to 52. Take 2 as common, n by 2 into 2. If you take 2 as common, remaining minus 8 plus n minus 1 is equals to 52. 2 get cancelled, 2 get cancelled, that is n into minus 8 minus 1 minus 9 plus n is equals to 52. Okay, n into minus 9 minus 9n plus n into n square is equals to 52. Rearrange the equation, n square minus 9n minus 52 is equals to 0. We use the factorization method here. 13 4s are 52, 13 minus 4, 9, that is minus 13 plus 4, we get minus 9n. That is n square minus 13n plus 4n minus 52 is equals to 0. Take n as common, n minus 30 plus 4 as common, n minus 13 is equals to 0. Okay, take n minus 13 as common, n minus 13 as common, that is n plus 4 is equals to 0. We know that 0 root a into b is equals 0, either a is equals 0 or b is equals 0. That is n minus 13 is equals 0 or n plus 4 is equals 0. N is equals 13 or n is equals to minus 4. Number of terms can't be negative, so we take n is equals to 13. N is equals to 13. Here 13 terms are to be added to make their sum is 52. Next, example 2. Example 2. Sometimes they are asking if A1, A2, A3 and so on, AN are in AP arithmetic progression, A1 plus A2 plus A3 plus and so on plus A pth term by a1 plus a2 plus a3 plus and so on plus a cubed term is equals to p square by q square, where p is not equals to q, where p is not equals to q. Then find the value of a6 by a21. Then find the value of a6 by a21. V is the formula Sn is equals to n by 2 into 2a plus n minus 1 into d. We know that Sn is equals to n by 2 into 2a plus n minus 1 into d. Here we want Sp. Sp means Sn means n by 2 into. Sp means p by 2 into 2a means here 2a1 plus p minus 1 into d. Sn means n minus 1. Sp means p minus 1 into d by Sq means q by 2 into 2a1 plus q minus 1 into d is equals to p square by q square. 2 get cancelled, p and p square get cancelled, q and q square get cancelled. Take 2 as common, a1 plus p minus 1 by 2 into d by, here also take 2 as common, a1 plus q minus 1 by 2 into d is equals to p by q. We want a6 by a21. a6 means a plus 5d, a21 means a plus 20d. Yes, 2 get cancelled here. a1 plus p minus 1 by 2 into d by a1 plus q minus 1 by 2 into d is equals to p by q. Compare here, a6 means a plus 5d, a21 means a plus 20d. So a1 plus p minus 1 by 2. Compare with 5, p minus 1 by 2 is equals to 5, p minus 1 is equals to 10, p is equals to 11. Compare with these two terms, q minus 1 by 2, q minus 1 by 2 is equals to 20, q minus 1 is equals to 40, q is equals to 41. As a6 by a21. If you substitute p value 11, 11 minus 1 10, 10 by 2 is nothing but 5. So a1 plus 5d is nothing but a6. If you substitute 41, 41 minus 1, 40, 40 by 2 means 20d, a1 plus 20d is nothing but a21 is equals to p by q. P value how much? 11 by q value 41. Therefore, a6 by a21 is equals to 11 by 41. Okay, next session we are discussing properties of arithmetic progression, selection of terms in arithmetic progression, some facts about in arithmetic progression. Next, arithmetic mean between two numbers, and arithmetic means insert between two numbers. Next, arithmetic mean of nth power. Next, some shortcuts we will discuss next video very soon. Until bye bye.